Welcome to Data Science using Python. This time we're going to look at a test on a proportion, on a single proportion. So here we don't really need a data set. We're just going to learn how to plug in the numbers like we did last time. But what we do need to know is a hypothesis. So let's suppose that we're interested in testing whether, let's see here, whether or not what's often called a supermajority, which is more than 66% of people agree with the proposition. And I'm not putting in the proposition because apparently YouTube doesn't like anything that has to do with politics, so I'm just leaving it with a proposition. All right, so we're just going to do a two-sided tale, even though this really should be a one-sided tale because we're interested in it being more than that. So we're just going to let P equals the proportion we're interested in, 0.66. And here we're going to have our hypothesis, which will be H naught. That would be actually P is equal to or less than 0.66. And versus H naught, that it's greater than that. P is not equal to, which is what we're going to do because first learn how to do this, then you can go look in the documentation to figure out otherwise. Significance level. How often do we want to be wrong on this? Or would we be willing to be wrong, not want to be wrong? We don't want to be wrong at all. So let's say 0. Maybe our proposition. If we're looking for a supermajority, then we probably want to be pretty sure that we're right here. So let's do 0.003. Okay, so we'll be wrong 0.3% of the time. All right, our test statistic is we're going to use all of this. Okay, and I'll put the function down. So copy and paste this. This is what we're going to use. And the function we're going to use is this function here. It's going to be proportions z test. And that's what we're going to use. Okay, so then we need to know our decision rule, which is if the p-value is less than alpha, we reject H naught. And now we can actually go and conduct our test, right? We've set everything up before we see the data, and that's really how you should do this. You should define all of this stuff before you ever see any data. That way you can stay objective. So suppose we survey 2,048 people and find that let's say 1,603 agree with the proposition. Right? So then we would just execute this. So we said we were going to use this. So SP proportion, and notice it comes up with a test or a list here, and we were interested in this one here. And notice you just punch in the information here. Notice here you can do the alternative is two-sided versus one-sided, but here we're going to have to put in a value here. So the count that we had was 1603. 1603. And the number of observations is 2048. And here we have our value that we're interested in is 0.66. Don't forget this because it's going to test 0.5 if you don't. Okay, and we can put in here alternative greater than if we wanted to. But right now we're just going to leave it at this and see what happens. So we're going to run this real quick and hope all goes well. And here we go. So we get our information that we need. I often like to copy and paste this stuff in so that later I don't have to run it again. So here we have our z-test, or z value, is 13.466. Now, that is not the p-value. The p-value is here. Now, notice this has e to the negative 41 on it. So there would be, 40 zeros in front of this, and I'm not going to type them all out. But it's really small. So you can put here, 2.47 times 10 to the negative 41, which is what that actually means. And this is a very, very small number. Okay, so then we can make a decision. Our decision is, since the p-value is equal to this crazy number, crazily small number, okay, which is clearly less than our 0.003, which is equal to alpha, we reject h naught. Okay, and so we can write a conclusion. Okay, we have sufficient evidence to claim that the proportion, if I can spell it, of people who agree with our proposition is not 0.66 or not 66%. And this is where you would want to possibly swap this out. Here, you can copy and paste this and put in, I believe in here, the alternative equals, in single quotes, I believe it's greater. We can try it and see what happens real quick. It says invalid alternative, and that's partially because this is a experimental thing inside of Python, but it should be something along this line. So, it should be smaller or larger. So, larger instead of greater. So it doesn't follow standard sort of what you would use. And notice the t-value is virtually the same. It is exactly the same. The p-value changed a little bit. So here you can use larger or smaller. So I'll put here smaller just so you have it. Those are your options, which we wouldn't want to run this one because this one would not reject. Because we have evidence that it is larger based on this p-value here. All right, so we're going to stop here. We figured out how to do a test on a single proportion, and in the next one, we'll look at creating a test on two proportions. So I'll see you there.